Assalamu alaikum. Our today's lecture is about solids and their types. Now, as far as these solids are concerned, solids represent the most ordered state of matter. They have got a definite volume, definite shape. Now, in terms of kinetic molecular model, solids have a regular order of the constituent particles. The constituent particles may be atoms, they may be ions, or they may be molecules. Now, the particles in solids are they are held together by strong these attractive forces. Now, as far as the characteristics of these solids are concerned, the important characteristics of these solids are they are rigid and have got a definite shape. Now, they have also got a definite volume. Now, the density of the solids is greater than those of liquids and gases. Similarly, these solids they are incompressible. That is, they can't be compressed as like those of gases, and we see in case of liquids. And similarly, many solids they have got a crystalline appearance and have got a definite patterns of angles and planes. Now, as far as diffusion is concerned, solids diffuse very slowly as compared to liquids and gases. Most of these solids, when heated, they change into liquid state. This process, as you know, is known as melting, and the temperature at which these solids they change into liquid state, and that is called as the melting point. Now, the melting point of these solids it depends upon the nature of the of the solids, and this melting points they vary widely. For example, in case of iron, if we see the melting point of iron, it melts at it has got a melting point of 1870 Kelvin. Similarly, we see in case of sodium chloride, it has got a melting point of 1075 Kelvin. Now, as far as the types of depend this types of solids are concerned, these solids solids are classified into four types depending upon the nature of the binding forces between these constituent particles, which may be atoms, which may be ions, or which may be molecules. Now we have got four types of these solids. We have got molecular solids. Now, as far as the molecular solids are concerned, in case of molecular solids, we see the constant particles are molecules, and these molecules are held together by weak van der Waals forces. For example, we see among the molecular solids we have got the common example we have got this, it is ice. Then similarly we have got solid carbon dioxide, we have got iodine. So these are molecular solids. Then, as far as another type of as these solids is concerned, we have got another type of solid, that is ionic solids. Now, in these solids, the constituent particles are ions, and the ions there are two types. We have got positively charged ions and negatively charged ions, and these ions, in case of these ionic solids, they are held together, or they are in a regular fashion throughout the whole crystal. Now, these the attractive forces between these ions, they are very strong, and they are electrostatic in nature. Now, for example, in case of these ionic solids, we see salts like NaCl, sodium nitrate, sodium sulfate, KCl. So these are the ionic solids where we see the constituent particles are ions. Then we have got another type of solid is that is solids that is covalent solids. Now, as far as these covalent solids are concerned, in these solids, the constituent particles, in case of covalent solids, we see the constituent particles are they are atoms, and they are held together by means of covalent linkages, or by means of covalent bonds. For example, the common example we see in this case, it's diamond. We have got this a covalent solid. We have got silica, it is also a covalent solid. Then we have got this silicon carbide, that is also a covalent solid. Now, then we have got another type of solid, that is the metallic solid. Now, in as far as these metallic solids are concerned, the constituent particles in these metallic solids, they are positively charged kernels. We see kernels, and these positively charged kernels, we see they are immersed in a sea of mobile electrons, and the forces present between these ions, these mobile ions, and these positively charged these kernels. They are metallic bonds. For example, we see these metallic solids. They include different types of we have got different types of metals. Now, as far as so this is these are the types of solids which have been classified on the basis of, or on the depending upon the nature of the binding forces which held the particles in these solids. So we have got molecular, ionic, covalent, and metallic solids. Then we have got another term, that is space lattice. Now these, as far as space lattice, now the crystalline solids, they have got a definite orderly arrangement of the constituent particles in a three-dimensional pattern. Now the position of these particles, or the position of these, they may be ions or ions in a crystal related to one another, are usually shown by means of points. We show these by means of pointers. But the arrangement of an infinite number or infinite set of these pointers, that is called as the space lattice. So space lattice, we can say it is a regular arrangement of the constituent particles, which may be atoms, ions, or molecules of a crystalline solid in a three-dimensional space. Now the positions occupied by the atoms or ions or molecules in a crystal lattice, and that is called as those are called as lattice sites or lattice pointers. Then we have got a unit cell. Now, as far as the unit cell is concerned, the unit cell, it is the smallest portion of a crystal lattice or a space lattice, which when repeated again and again reproduces the complete it reproduces the whole crystal or the complete space lattice. Now the smallest this smallest repeating pattern, it can represent the shape of the entire this crystal. Also, while describing this the shape of this unit cell, we see the length along the three axes, that is that they are called the edges of these the length of the edges of this unit cell, it is represented by we have got A, B, and C. Then we have got the angle between these edges, that is represented by alpha, beta, and gamma. So this is about this unit cell and the space lattice and the types of these solids. And in our next this lecture, we will discuss the packing in case of these close packing in case of these crystalline solids. So this is for today. Thank you very much.